Good evening, my YouTube viewers. In this video, what we're going to do is we're going to perform a hypothesis test using the Bernoulli distribution, and it's going to be a 1/12 lower test. So the question we have is, a hospital claims that the rapid diagnostic test correctly identifies a disease 95% of the time. You randomly test 40 patients and 34 of the return of a correct diagnosis. At the 5% significance level, is there evidence to suggest that the test is less accurate than claimed? So your significant level is 5% being an alpha, and the claimed accuracy is 95%. The sample size is 40, and the observed correct diagnosis is 34, and the observed accuracy is observed correct diagnosis of 34 divided by 40. So 34 divided by 40 is 85%. So you have a claimed accuracy of 95% and an observed accuracy of 85%. So we have a standard error, which is the square root of B8, that's your claimed accuracy, 95%, times 1 minus B8, so that's 5%, divided by B9, that's your sample size. And then you take the square root of that, and your standard error is 3.446%. So we're going to calculate our z-score. The z-score is B11, that's your observed accuracy, minus B8, that's your claimed accuracy. So that's going to give you 10. So B11 minus B8 is negative 10 divided by B12. That's your standard error, and it's going to give you a z-score of negative 2.9. So we're going to take our p-value. It's norm.s.dist, and S means it's a sample. Brackets B13, that's your z-score, and it's true. So we take the z-score, and you get a p-value of 0.001. So because 0.001 is less than 0.05, you already know that you're going to have to reject the null hypothesis. So the null hypothesis is there is no significant difference between the claimed accuracy and the observed accuracy. And the alternate hypothesis is there is a significant difference between the claimed accuracy and the observed accuracy. So now we're going to interpret this, although we know that since the p-value is less than the alpha or the significant level, then you're going to have to reject the null hypothesis. We're going to go ahead and do it the Excel way. If B14 is greater than, would you say, or equal to B7, that's your alpha, fail to reject the null hypothesis. Otherwise, reject the null hypothesis. So we're rejecting the null hypothesis, so that means there is a significant difference between the claimed accuracy and the observed accuracy. And so what we've done is I've made a little chart for you, and the claimed accuracy is 95% and the observed accuracy is 85%. So that concludes this video. The next video, we're going to perform a hypothesis test using the Poisson distribution, and I hope that you decide to watch it.